Hello, my name is Bruce Caldwell. I'm the director of the Center for the History of Political Economy at Duke University. And it's my pleasure to welcome you to another talk in our Hayek lecture series. The Hayek lecture series is sponsored by the Thomas W. Smith Foundation and sponsored on campus by two groups, the Hope Center and the program in Philosophy, Politics, and Economics. Our speaker today is Dr. Bjorn Lomborg. Dr. Lomborg is the president of the Copenhagen Consensus Center, a think tank that researches and publishes the smartest solutions to the world's biggest problems. He's also a visiting professor at the Copenhagen Business School and a visiting fellow at the Hoover Institution at Stanford University. In 2004, Dr. Lomborg was named one of Time Magazine's 100 most influential people for his work on climate change and the environment. His books include The Skeptical Environmentalist and his most recent, False Alarm: How Climate Change Panic Costs Us Trillions, Hurts the Poor, and Fails to Fix the Planet. Today, Dr. Lomborg will speak about climate change and effective policy, asking the provocative question, is alarmism wasting trillions? He'll speak for about 45 minutes. During his lecture, you can use the chat function to send in any questions that you'd like to have answered during the Q&A period. And at the end, I'll pick a subset of those questions to direct to Dr. Lomborg. It's my pleasure now to ask, or rather to turn the virtual podium. We can't let him stand up here. Virtual podium over to Dr. Bjorn Lomborg. Bjorn, nice to see you.
Bruce, thank you very much. And it's wonderful to meet all of you guys. And again, I'm sorry I can't be there. And I'm especially sorry that we don't have wine and cheese afterwards. So what I would like to do is really just spend the next 45 minutes walking you through how I think we should be thinking about climate change, posing some of the points that we know from the science, and especially on the economic side, and thinking about how do we make smart climate policy. Given that this is a very, very large topic, I hope you'll excuse me for trying to do this very effectively and also fairly quickly. It means that there's going to be some things where you're thinking, what? And then, of course, please feel free to ask Bruce to ask me what are the right way to think about this. So let me just, without any further ado, go ahead and share my screen. This is always sort of the most worrying part of any Zoom presentation. Hopefully you can actually now see my my screen, and I'm just simply going to go on, and hopefully you will enjoy the points here, and I'll look very much forward to your questions. So fundamentally, climate is a real issue. Look, global warming is real, it's man-made, it is something that we should be concerned about, but it's often vastly exaggerated. And that has negative consequences, because if we think this is a problem, we're likely to tackle it with reasonable approaches. If we think this is the end of the world, we're likely to throw everything in the kitchen sink at this. Let me just show you, there's lots and lots of these exaggerated claims. I'm just going to show you one from our Secretary General of the UN, Guterres, who has said lots of these things. So he tells us the world is facing grave climate emergency. Every week brings new climate-related devastation, floods, droughts, heat waves, wildfires, superstorms. We're in a battle for our lives, and climate change is the biggest threat to the global economy. All of these things have a slight kernel of truth and a lot of misdirection, and I'm going to try and show you some of this. That matters, again, because if we're too alarmed, we're likely to be spending too much money, and often badly, on tackling climate change, and of course forgetting all the other challenges that we also need to address. So let me just show you a few of these conversations that Guterres talks about. Again, I can't go through all of them in 45 minutes, so let me just show you a few of them. Drought, he says that we see more and more drought. Well, actually, if you look at the total area of severe drought over the last century and up till 2017, what we see is a slight decline. Whoa, I would have liked to have seen, there you go. I'm sorry, I'm not sure why that didn't animate. But anyway, what you see is not an increase, actually a slight decline over the last 15 years. The point here is not to say that there's no problem, but it is to say that the sense we get that everything is escalating out of control is just not correct. Now, what does the UN actually tell us about drought. The US Climate Change Science Program, which is the UN's climate panel in the US, tells us drought has, for the most part, become shorter, less frequent, and cover a smaller proportion of the US over the last century. This is the latest 2018 report. I bet that this is counter to what most people think when they talk about drought in the US. The UN climate panel, the IPCC, tells us there's low confidence in a global scale observed trend in drought. What they do tell us is the future, there's medium confidence that droughts will intensify in some seasons and areas, overall low confidence elsewhere. So what they are telling us is in the future, it is possible that we will see more drought. And this is a continuing point. Up to now, we can't actually see that there has been this terrible development that we're being told, but there is a problem. This is one of the reasons why global warming is a real problem. It is something that we need to tackle, but we also need to get a sense of proportion. And that's what, of course, what I'll get back to. Let me just show you two other things. So flood, obviously one of those big things that a lot of people talk about. It has lots of great visuals. I'm just showing you one of them. And what that tells you is, are we getting more floods? Well, the UN climate panel actually puts this very bluntly. There continues to be a lack of evidence and thus low confidence regarding the sign of a trend in the magnitude and or frequency of floods on a global scale over the instrumental record. Actually, we don't even know if floods have gotten worse or better. We just don't have that data. Again, if you look at the impact, and this is an important distinction because we know that even if you have worsening climate impacts, the actual impact on society depends a lot on your ability to handle that, on your resilience. And so if we look, and I'm going to show you a lot of US data just simply because you have the best and the longest term data. If we look at US flooding, the cost of US flooding from 1903 until today, what we see is the dramatic decline in the early part of last century. The average cost was about 0.5% of GDP every year. Today, that number has declined by about 90%. It's down to about 0.05. So again, it's not that we're seeing ever worse floods, that we're seeing a problem that is getting way out of hand. If anything, what we're seeing is a problem that we can more and more easily handle. This is not to belittle the people who actually have a big problem with flooding, but it's simply to say, on a societal level, this is not a problem that is spinning out of control and getting worse and worse. It's actually a problem that we are better and better able to handle. If you look at the last thing, hurricanes, it's also the most costly natural disaster that's typically coupled with global warming. The UN climate panel actually says, globally, there's low confidence in attribution of changes in tropical cyclone activity, that's what they call hurricanes, to human influence. Most people agree, and most institutions agree, that we can't actually see an impact today. But in the future, yes, we will see not more hurricanes, actually we'll probably see slightly fewer, but we will see stronger hurricanes, and that will actually overall be a net negative. So there is a problem again, but if you look, and this is the best data that we have back in time, if we look at US continental landfalling hurricanes, remember they're much, much easier to get noticed also back in time, whereas if you just look out in for instance, the Atlantic Ocean in sort of around 1930, 1940, very, very few hurricanes were noticed because we just opened the Panama Canal and there was virtually no ships out there to notice. Of course, today we notice a lot of them because we have satellites. So if you look at continental landfalling hurricanes, this is probably the best measure because it is very likely that if there was a hurricane, someone would have noticed that it hit land. And what we see is a slight decline. Again, it's not significant. The point here is it's not increasing. And people are also worrying about that we're seeing more strong hurricanes. Again, that's not what we actually see if you look at the number of major hurricanes. So category 3 and above, we've seen a slight decline, not an increase. Again, all of this is not to say that there's no global warming, and certainly not to say that it won't be a bigger problem in the future, but it is to get a sense of proportion when we're told constantly and over again that we're seeing more floods, more droughts, more hurricanes. That's actually wrong. Mostly, we're seeing about the same, and mostly that damage is actually declining, not increasing. So why is it we get it so wrong on global warming? I would argue that one of the major reasons is we miss the fact that we're actually a pretty adaptable species. I'll show you this in a couple of different ways. If you look at how many people die from climate-related disasters over the last 100 years, so we have good data from about 1920 until today, most people would probably, given the current way that we talk about it, imagine that things are getting worse and worse. It's sort of exploding upwards. We're seeing more and more people die. You'd be entirely wrong. This is from the International Disaster Database, and what we see climate-related deaths, so floods, droughts, storms, wildfire, and extreme temperatures. We've gone from a world where about 500,000 people, almost 500,000 people died every year on average. Remember, these are very, very fluctuating numbers, so these have been averaged over each decade, from almost 500,000 people every year in the 1920s to about, or a little less than 20,000 last decade. Actually, 2020 is just down at 8,000. But again, it's just 1 year, so it may fluctuate. What this tells us is we've seen a dramatic decline of about 96%. And remember, at the same time, the human population has quadrupled over this time period. So what we're actually seeing is the death risk has reduced by more than 99%. This has very little to do with climate, but it has everything to do with our climate resilience. That is, we're much better able to handle the problems that we see from climate. So we have, because we're richer, we're better equipped. We also have better safety procedures. We have more prognostic tools and so on. We're much better able to handle this. This does not tell us that we're in an impending crisis or catastrophe mode, or that this is an existential threat for humanity. It tells us this is a problem, and actually a problem that we typically tend to handle better and better, not worse and worse. So why is this? This is because of adaptation. So let me just show you this. This is one, there's many of these models out there. This is one of the models that have looked across most of the other models looking at future flooding. This is very, very good because we know this is one of the absolutely certain outcomes of climate change. We're going to see rising sea levels, somewhere between 1 and 3 feet of sea level rise by the end of the century. This is not a trivial issue. So clearly, this is something that's going to challenge humanity. But let's take a look at this. So in 2000, we estimate, and again, these are model estimates. This is average of 3 models because it's a very soft number, exactly how many people flooded. It's much easier to look at dead, but that's very, very few. So we look at the model estimates. 3.4 million people were flooded on average per year in 2000, the year 2000. And again, remember, this is a model estimate. The cost of all of these floodings were about $11 billion. These are all inflation adjusted. The cost of dikes, so the cost of protection, was about $13 billion. The total cost, so the 11 plus 13, so the $25 billion, is equivalent to about 0.05% of global GDP. Now, what will happen, and I'm just going to show you one of these, but they do it for all of the different scenarios from the UN. They show pretty much the same. I'm just going to show you the worst case warming, the highest population, and the highest GDP. So the people who actually have the most to lose from climate change. What will happen if you just assume that sea levels are going to rise and nobody does anything about it? This is what you see. If you have no adaptation, we will go from about 3.4 million people being flooded to 187 million people being flooded every year. This is not very surprising. If you don't do anything about dikes, sea levels rise up to 3 feet. You're obviously going to see a lot more people being flooded. This number recurs. It was first done in 2011. It just reoccurred last year, and it was a headline in Washington Post and many other places, that global warming will lead to 187 million people being displaced because of global warming. Some Rolling Stones even go that step further and say 187 million people are going to drown. Of course, that's not actually going to happen because you'll have time to move, but this is still a terrible outcome. It'll have a cost of $55 trillion in total cost. The dike costs are not going to be very much because you're simply upkeeping the old, very, very low dikes. In total, this will cost 5.3% of global GDP. It's also phenomenally unlikely to happen, of course, and the modelers themselves say this is not going to happen. Of course, no government is actually going to say we're going to be much richer, hence we'll want much more protection. Sea levels are going to rise, we'll want more protection, and we can afford to do so at very low cost. Of course, we're actually going to invest in protection. What will happen if we assume reasonable investment in protection? This is what they show. We will actually, with a realistic adaptation, see 15,000 people being flooded. So a dramatic decline, despite the fact that sea levels have risen almost 3 feet. The cost will have increased, yes, but of a much, much richer society. The dike cost, of course, has also increased because we actually have to spend a lot more on dikes, but the total cost compared to GDP will have almost fallen by 90%. It'll be 0.008%. Notice, I think this picture shows us very clearly what's wrong with much of the climate conversation. Yes, there is a problem. As sea levels rise, if we do nothing, we will be much, much worse off. But of course, we won't do nothing. We'll actually do what humanity has done for the last 7,000 years, what Holland has been doing for the last couple hundred years. And if we do anything near that, we will have to pay more. We will have more costly impact, but this will mostly be because we're much richer and many more people are close to where harm's way will be. But actually, fewer people will be impacted, and in percent of GDP, the cost will actually decline significantly. This does not mean global warming is not a problem. Had we had no global warming, the cost would have been even lower. They haven't actually modeled that, but let's just say the cost would have been 0.004% of GDP or something like that. So clearly global warming has an impact, but it's a very different kind of impact to say global warming means it won't get quite as good quite as fast. Instead of saying, which is what most people hear and what most people are saying, global warming will make the world almost unlivable. There's a huge difference both in how we tackle this politically and how we think about what are the kinds of things that we should be investing in. I argue that for most of these things, and I'll show you the documentation for this later on, that for most of these things, we have very good understanding of why the worst case scenarios that are often bandied around are just not anywhere near to what's actually going to happen. So if I can just show you one other way of looking at this, and we have many other studies showing the same thing, but just the global cost of climate damage from 1990, when we've had the first sort of good data for the whole world, despite what you think, we've actually seen a decline. We've seen a decline from about 0.26% of GDP in 1990 down to about 0.18%. Not what you hear and what you think and what is often reported, that it just gets ever worse. No, actually, there is an increasing in absolute cost, and that's mostly because we get much richer. When you have twice as many houses that are twice as much worth each one of these houses, you will see 4 times the damage. But if you adjust for that, which is what the UN also says we should be doing, the cost is actually declining, not increasing. So what does that mean we should do about this? Because as I just pointed out, global warming is a real problem. It's something we need to tackle. It is something we should be honest and say, we need to find a way to fix this problem. Not the end of the world, but it certainly is a problem we want to fix. Unfortunately, so far, our climate policy has mostly done to show us how not to tackle climate change. So if you look at what has happened over the last year, UNEP, the UN Environment Program, actually in 2019, I think very underreported, told us despite all the arguments that we've had for the last 10 years, trying to do all kinds of things, the Paris Agreement and so on, we have basically seen a decade lost. What they tell us is that the emissions today, remember this was before COVID, the emissions today are almost exactly at the level of emissions projected for 2020 under the business as usual or no policy scenario. So basically the last 10 years that we have been talking a lot about climate, we've been trying to enact all these climate policies, we have achieved virtually nothing. I think that is astounding given the amount of focus that we've had on climate. We also know that much of what we have proposed to do will have very little impact, but actually quite a bill. So if you take the Paris Agreement, according to the UNFCCC, the guys who organized the Paris Agreement, who did the first assessment of its impact, the total cut of all the promises from the Paris Agreement in 2015 was about 63.5 gigatons of CO2 equivalent by 2030. To most people, that means nothing. But what that means is if you actually run this in a climate model, it means the reduction in temperature by the end of the century of 0.029 degrees Celsius, or about 0.05 degrees Fahrenheit. That means we will basically not be able to tell the difference in temperature by the end of the century, even if everyone did their Paris Agreement promises. And of course, remember, we've never actually seen a climate agreement where everybody has done what they promised. They typically deliver much, much less. It will reduce the temperature, if we just assume business as usual for all other participants, from 4.1 degrees centigrade by the end of the century, that's about 7 degrees Fahrenheit, to 7.071 degrees. So it's the equivalent of going from, what, 7.1 degree Fahrenheit to 7.05 degrees Fahrenheit, right? We probably won't be able to measure the impact in 80 years. It will cost, if you run it with the best climate model, with the best climate economic models that we have from the Stanford Energy Modeling Forum, which is sort of the best collection that we have of all the models that have run something similar. They're actually running a new estimate and it'll come out next year. But for now, I'm relying on the slightly older models from 2013, 2015, who did the estimates for individual countries. The cost end up being somewhere between 1 and 2 trillion. Spending 1 to 2 trillion, remember, that's not going to bring us to the poorhouse, but it is 1 to 2% of global GDP. To achieve almost nothing is a very bad deal. Each dollar estimated will avoid about 11 cents of climate damage. So if you try to make the estimates of all the benefits of all the future damages that are going to occur from climate change, you will have spent $1 and avoid about 11 cents of climate damage. A pretty poor deal, a bad way to try and help the world. One of the other things that I do, and Bruce just quickly mentioned that, is that I work with the Copenhagen Consensus, where we look at a lot of other things that you can do to help the world. So, you know, if you care about poor people, you can help them not die from tuberculosis or malaria or COVID. You can also help them not dying from malnutrition, or have their kids be smarter simply because they don't get malnourished as kids, or get better education. There's lots of other things that we can do. And many of these best investments deliver $40 to $100 back in the dollar. In that way, climate policy like we're doing right now in the Paris Agreement is a terribly bad policy. Not only does not actually deliver $1 back in the dollar, where you could just have distributed and done better, but it actually destroys welfare by saying we spend $1 and only deliver 11 cents of climate benefits back. If we do Paris for the rest of the century, that means, of course, we're actually going to see much, much higher losses, because we'll have that $1 to $2 trillion cost every year for the rest of the century. We will see about 0.17 degrees centigrade reduction, or about 0.3 degrees Fahrenheit by the end of the century. So again, something that'll be very hard to measure in 80 years, and it'll cost us somewhere between 60 and 120 trillion dollars in cost. So lots of cost, very little benefit. That's the basic point of why we need to think about how can we deliver better. One more thing, and Bruce also quickly mentioned it in my latest book, points out, this is also actually harming the world's poor. Remember, we very often say, and rightly so, climate will harm the world's poor the most, which sort of suggests that we should do climate policy that will actually help the world's poor. Unfortunately, Paris Agreement and many other climate agreements that we're talking about will be phenomenally expensive. They will not help very much with climate, so they will not actually help the poor very much, but they will lead to more poverty, or to less people climbing out of poverty. We actually have good evidence that show the Paris Agreement will lead to about 4% more poor. For most of the world's poor, of course, one of the big problems is they want more access to energy, and currently that will be mostly from fossil fuels. Many studies show that there's an enormous benefit from access to electricity. We did one study together with University of California in Berkeley with a climate economic model showing for Bangladesh, obviously a very potentially very progressive country in the sense that they have huge economic growth. They have lots of opportunity, especially for women through the garment industry, but they also want more power, because that way they can make more money, they can grow their economy more. Much of this energy is going to come from coal-fired power plants. So we did the estimate of what would that actually take. Sheikh Hasina, the Prime Minister's plan to build a series of coal-fired power plants. Now, this would definitely lead to higher CO2 emissions. That's bad, because it would lead to more climate change. We estimate the total long-term negative impact is going to be about 0.6 billion in long-term climate damage. That's terrible. That's bad. That's something we should be concerned about. But the benefit to Bangladesh would also be to grow their economy, and this CG model actually estimate the net benefit will be in the order of $258 billion for Bangladesh, and especially for Bangladesh's poorest. It would actually give about $1,000 back for every Bangladeshi by 2030. So we're asking, when we tell Bangladeshis not to do this, when we're telling them, no, you need to sign up to Paris and to stronger policies like Paris, we're asking them to forego benefits of $100 in order to reduce climate damages by 23 cents. That's probably not the best way forward. And of course, remember, if we actually want to help Bangladeshis, at least we should have that conversation of saying, would we do that ourselves? No, we wouldn't. Most of the world, both in Europe and the US, have gotten rich on using lots and lots of fossil fuels. Now we can afford to switch to other resources. Not well, but we can certainly afford to. Why would we then go and say, and so other and much poorer countries should do the same? This goes to saying, so how should we actually fix climate change? So what I'd like to spend the rest of my time on, and again, I'm sorry, I would love to talk a lot longer. I'm sure you'd like me to talk less, but I'll spend my last 15 minutes talking about what should we actually do. I have 5 main points. So I'm going to go through them. I'm going to spend most of the time in the first 2, and then I'm briefly going to talk about the other 3 policies that we should focus on. It's going to be a carbon tax. It's about innovation, about adaptation, and it's about geoengineering and prosperity. So I'll go through each one of them in turn. So I think everyone agrees, everyone certainly in the economics sphere, that we should have a carbon tax on CO2. Look, when you have a climate problem, you basically fix it, and this is sort of standard economic theory, you fix the misinformation problem or the externality problem by pricing those externalities. And that way, when you make an action, you actually know how much damage this is going to infer for humanity down the line. So that's why you have a carbon tax. The important part of this insight, and I'm basically going to use this from Nordhaus, William Nordhaus, economics professor at University of Yale. He's the first and only climate economist to ever get the Nobel Prize in climate economics. He got it in 2018. I'm going to rely a lot on his models. It's a very standard model, and it's mostly, I think you can reasonably say, the most respected and certainly the most cited integrated climate model that we have. The main insight in what should we do about the carbon tax is to realize that, yes, climate means costly damages, but climate policy also have costly damages, namely to the economy. Since we have to pay both, we have to find a place where the total cost of those damages are at a minimum. That's basically one of the things that Nordhaus got the Nobel Prize for. So let me just show you, and this is again a quick version of what he shows is the impact from climate change. He does this over the next 500 years. What is the cost of climate change? And this is his summary. This is all the major studies that have been done in showing what is the net impact, and typically it'll be a net negative impact from climate change for higher and higher temperatures. So as you can see, the temperatures get higher and higher, it gets warmer and warmer out the x-axis, and as you go further out, you also get more and more damages. So this is what he estimates is the best regression. He's also made different estimates, that's the size of the circles, of how good these estimates are. So very small circles, not very much confidence, big circles, really good studies that seem to indicate what we know about what will be the total damage globally across all areas for all relevant impacts over the next 500 years. Again, of course, this is a very big challenge, and we're certainly not sure that we've picked all of them. He actually also makes an estimate of saying, look, we probably have omitted some damages. This, he adds, is then the blue line. The blue line is the one that I'm going to use for the rest of this presentation. So this shows us how much damage. We estimate that by the end of the century, if we don't do anything, we'll end up at 4 degrees centigrade or thereabouts. and that will lead to damage of almost 4% of global GDP. It tells us global warming is a real problem. It's certainly a big problem. It's 4%. It's also important to say it's not 100% or anywhere close. So it's not this existential problem that people are talking about, but it certainly is a problem. If we can find a solution that is significantly lower than 4%, or at least that can fix all of the 4% for almost 4%, that'd be a good deal. But the real challenge is that we often find solutions that will cost 12 or 16% of GDP and only fix a smaller part of the 4%. That's a bad deal. I'll get back to that. So what he shows, and this is his basic DICE model, if we assume that 4.1 degree centigrade is what we're going to get with zero policy, and again, these are just the temperatures by in 2100. Actually, he goes over the next 5 centuries. I've just named them to have some sort of sense of where we are at by 2100. If you look at that cost, it's going to be $140 trillion for the world. That's a huge cost, and clearly this is something that we should try to avoid. Let me just go through these others. If you have 3.75 degrees, there should be a degree centigrade. Sorry, I'm missing that. It's about 105 trillion. 3 degrees is even less, 2.5. And in his model, the lowest that we can get is 2.15 degrees centigrades. That's the absolute lowest cost. This seems to suggest exactly what almost all climate policy makers, sorry, I'm just going to get some tea. What all climate policy makers are saying, and certainly all green campaigners are saying, look, we should be going for 2.15 degrees. It's where we leave the least damage for the world. And if this is the only graph you see, that sounds like a very, very sensible thing to say. It makes a lot of sense. But as I mentioned before, this is not the only cost. There's also a climate policy cost. Now, if you have no policy, you have no cost. I've just shown you the no policy cost, it's zero. If you make a policy of 3.75 degrees, there's a slight cost. It's about $20 trillion. This cost is mostly the lost growth cost of choosing to force people to use slightly more costly, slightly less effective, slightly less reliable energy sources. This, again, is not something that's going to take us to the poorhouse, but it's a real cost. And we need to take that into account. So 375, it becomes a little bit of a cost. For 3 degrees, it becomes much more of a cost. It's almost $100 trillion. 2.5 is immensely expensive, and the lowest, 2.15, is suddenly incredibly expensive. The point here is to recognize we have to pay both of these costs. So not only do we have to pay those costs I just showed you here, the climate costs, those are the ones that seem to suggest, well, we should just go for the lowest cost, sorry, the lowest temperature. We also have to pay the climate policy cost. I've just added the climate policy cost to 4.1, then I'm adding the cost to the 3.75, adding the one to 3 degrees, and so on. What you now see here is what Nordhaus points out, this is the optimal place. So we should place a carbon tax that actually leaves us with a significantly lower temperature, 3.75, rather than 4.1 degree by the end of the century. A lot of people are going to be like, oh, we need to go much, much further down. But that's because we have become accustomed to only looking at the black bar and not the gray bar. We need to look at both of these. And if we actually want to leave the world a better place, we have to accept we have to pay both. These are both places where we're not going to get as much welfare as we could otherwise get for the world. That's why the 3.75 is actually the optimal. Remember, this is still an outcome where we more than half the emissions of the world across the century. That's a significant decline, and I would argue probably also more than we'll probably realistically see. This is simply the argument of saying we need a carbon tax, but we also need a realistic and rational carbon tax. That means one that will get us to 3.75. This means something where we can coordinate the carbon tax across all areas within the US and other nations, and across all nations, that is both China and India and Russia and the US and the European Union and everybody else, which of course is a very, very hard task, and also coordinate it across the century. This is assuming that we're going to fumble somewhat through this. That's the cost that I'm showing here, but it still shows us that we need to be realistic, that yes, it can solve some of the problem, but certainly not most of the problem. If I can just show you very, very quickly, this is just basically showing you the total net worth of the next 5 100 years. It's about $4,500 trillion in constant US dollars. What we see here is we are going to have a loss from climate policy. If we do nothing, it's going to be about 3%. So we'll have 97% left over for the good of humanity. If we do it smartly, we can actually reduce that to 2.6. We'll have lower loss. We should definitely try to do that. But what you should also notice is as we try for lower and lower temperatures, we're actually going to see higher and higher losses. So it's very plausible that in our attempt to try to do good, we will end up making the world worse off because we will waste more money. Yes, we'll reduce temperatures further, but we will do so through much, much more wasteful climate policies. So my point here is simply to say, we should definitely aim for a carbon tax. We should also recognize its limitations, and we should recognize that if we go too far, which obviously is what almost all climate policymakers have argued for so far, they've all said we want to go for 2 degrees or even below that, we could very easily end up making the waste for humanity or reducing the amount of welfare for the rest of the next 500 years much, much more. So it's not just do as much as you can, it's actually do the smart thing. And again, alarmism doesn't help us. It actually leads us to wasting trillions. But that was just one of the impacts we should be doing. We should also be looking at innovation. So again, one of the things I think we need to recognize is that most things we've solved through humanity, we've not solved by telling people, I'm sorry, could you do with less? If you think back in the 1860s, the world was hunting whales almost to extinction because whales had that wonderful opportunity that they gave this oil that burns really, really cleanly. And that means you could go away from camphor and other very polluting oil sources, and you could get very clean, much brighter lights. And that lit up, whales lit up much of Western Europe and North America in the 1950s, 1960s for all the people who could actually afford it. That was why we were hunting whales to extinction. The solution to hunting whales to extinction was not to tell everyone, I'm sorry, could you turn down the light and go back to more sooty alternatives? Of course, that would never have worked. What did work was that we found petroleum in Pennsylvania in 1862. And suddenly that was a much cheaper and much better alternative than whales. And so we basically stopped hunting whales. We went back to it in the 1900s for other reasons. But the main point here is, again, to recognize if we have innovation, we can make people switch and stop hunting whales, or we can fix climate change. So again, don't try to ask people to do with less. That's not an attractive policy. A lot of people, when COVID started out, was like, see, now the world is stopping flying, they're stopping driving, they're consuming less. That's wonderful. But of course, actually, most people don't want that. Most people don't want a world where they have to live with less. It's very, very hard to imagine that this is going to be a winning strategy for most policymakers. And certainly suggesting that we should have lots of shutdowns like we've seen with COVID be a winning policy strategy across the world seems to stretch credulity. Instead, we should basically make sure that we innovate. So what I'm proposing, and again, this is an outcome of a process we did together with 27 of the world's top climate economists and 3 Nobel laureates to look at where can you spend $1 and do the most good for climate. And what we found, this is also one of the things that have inspired Bill Gates, is the best climate policy is actually to invest dramatically more in investment of green energy research. Because if we focus on research and development in green energy, then if we can develop future green energy sources that are cheaper than fossil fuels, everyone will switch. It'll not just be green, rich, well-meaning Americans and Europeans who will switch a little bit, but it'll actually be everyone, including the Chinese, the Indians, the rest of Southeast Asia, the Africans, and the Latin Americans, which will actually be emitting 3/4 of all CO2 this century. So if we can innovate the price of green energy down below fossil fuels, we're done. Everybody will simply switch. So just to show you, and this is, again, it's a little bit facile, but it tells you the simple story. The EU has been cutting a significant amount of CO2 with wind and solar, but they're also paying about $40 billion a year in subsidies. The US shale gas revolution has actually made you guys richer, and it has cut CO2 emissions in the US dramatically because it has made gas cheaper than coal, and that's why a lot of utilities have switched away from coal towards gas. It burns much more cleanly. This is not predominantly a climate policy, but it burns much cleaner and burns with much less CO2 emissions, about half the total emissions. And so what the US has actually managed to do is to make, and again, this is just one estimate, about $300 billion more per year because of the shale gas revolution, and actually cut 3 times as much CO2. My simple point is to say, if you ask people, do you want to pay a lot and cut less CO2, or do you want to make a lot of money and cut more? You will obviously be picking that second option. Most of these options that we're going to see in the future are obviously not going to be as nice, but the simple point is, if we can invest a lot more in research and development, we're much more likely to actually get a solution that will work not just for rich countries, for also for everyone else. That's why on the sidelines of the Paris Agreement, Bill Gates and many others, we also pushed, we had a very, very small part in this, pushed for a promise to double green energy R&D funding by 2020. Obama, a lot of other world leaders promised to do so. We've spectacularly failed. It includes both the US, the EU, China, and India. But unfortunately, if you look at all of the OECD, we've not seen an increase since 2015. We've not seen that for the US either. Here are the promises. So unfortunately, we have promised the right and the smart thing, but we're not delivering on this. This is one of the things that if we stop being so panicky, if we stop having this very, very wide conversation about we're all going to be, this is going to extinct the human race, we need to throw everything in the kitchen sink at this, we focus a lot more on just putting up new solar panels and wind turbine parks, instead of actually focusing on the things that will really fix it, namely a carbon tax, and especially here, innovation. So just to give you a sense of proportion of what works and what doesn't, we have economic studies that show that the EU 2020 climate policy, the one that was finished last year, probably delivered about 3 cents of climate benefits for every dollar spent. The Paris Agreement, as I mentioned, delivers 11 cents back on the dollar. A smart global carbon tax actually delivers $2 back on the dollar. It has a significant cost because it slows down economic growth, but it has more benefits in terms of actually reducing future damages from climate change. But innovation, we estimate, and again, this is very hard to say because we're talking about what will happen in the future, but we estimate, looking at other investment in research and development, that every dollar spent, and we're suggesting we should 6-fold increase our spending up to about $100 billion a year, which is also a little bit aligned with what President Biden is promising. It could deliver $11 of benefit for every dollar spent for the world. That's a great investment. It's not the best investment in the world, but we're certainly a smart species. We can afford to do several things. This is one of the things that would actually deliver goods. I have just 2.5 minutes back, so I'm just going to show you the last 3 impacts. Adaptation. Simply, we need to remember adaptation is also a smart strategy. That was what I tried to show you before. Most of this adaptation will actually happen because it's smart, privately smart, but some adaptation like sea level rise is necessarily public. You can't just build a dike for yourself. It turns out that often the paybacks are very, very large, and we should definitely be doing this. Many of the policies are also smart, but they're not nearly as impressive. But again, we should be focusing on this. We forget that when we talk only about the end of the world. But if we think more smartly about this as a problem, we're also more likely to think about adaptation. Geoengineering, I'm basically just going to point out this is a way that we could adjust the global temperature. We are not proposing, and I'm certainly not proposing, that we should go ahead with this, but because it's potentially so cheap, we should do R&D to make sure that it actually has net positive impacts, because it's so cheap that it's realistic that a very motivated NGO or a rich billionaire might just decide to give this to the world and basically turn down the temperature for the world. And we want to know if that has bad consequences. And if it doesn't, we also want to know that this could be a policy safe, backup policy if all else fails. So I'm not going to go into this, just simply recognize this is very, very cheap. We estimate it potentially has a benefit for about 2,000 back in the dollars. We estimate the total cost is about $9 billion over the 21st century. The net benefit would be about 60 trillion, mostly in avoided control costs. So potentially a huge benefit, but again, look at this, but don't take this as the starting point right now. The last bit I just want to mention is we need to recognize, and we often forget this, that one of the things, and I showed you that graph in the beginning, how we've seen dramatic declines in deaths because of more welfare, more prosperity, being more resilient. Prosperity gives us the opportunity to do many of the things that we can't do if we're not rich. Most of the people who are going to be hurt by climate change are the world poor. So it's a reasonable question to say, would it be better to make these people rich or to protect them from climate change? It turns out, this is just Schelling conjecture, one of the Nobel laureates that we actually work with, he suggests that maybe it's better to actually make them rich. Turns out that that is indeed true. I'm just going to show you this one graph here. This is if we do sustainable development. This is one of the proposals from the UN. It's a pathway. We're likely to end up seeing the world being about $100,000 per person per year by the end of the century. And they also suggest if we do fossil fuel development, obviously we'll be using a lot more fossil fuels. We'll also emit more CO2. There'll be more warming, but we'll also actually leave the world phenomenally much richer. Will be at about $180,000 per person per year. Remember, these are all UN scenarios. But remember, there's also going to be climate damage. So if we deduct that climate damage, the actual outcome is it will still be about $100,000 for sustainable development. There'll be much more damage from climate change from the fossil fuel development, but we'll still be a lot richer. The real question is, which pathway would you like to be on? If you're just focused on climate, you'll obviously say the sustainable development. But if you're actually focused on making people better off, maybe there is an argument to say you should be at fossil fuel development. This is also true for Africa. And I just simply want to point out here, if you look at Holland today, and this is the three different outcomes for Bangladesh, depending on what kind of outcome we choose. If we focus on the middle of the road, which is probably the most likely outcome, Bangladesh will be as rich as Holland in 2100. Of course, they'll also be able to afford the same level of protection as Holland has today, or possibly even more because of technology. But remember, if we actually focus on a richer world, so the sustainable world, or even the fossil fuel world, we could actually make them as rich as Holland is today in the 2060s. The question is, isn't that better to focus on making sure Bangladesh gets as rich as Holland already in the 2060s so that they can handle better climate and, all the other things like getting their kids better education and avoid dying from easily curable infectious diseases? Those are the main points. So I simply want to emphasize that, yes, climate change is a real problem. It costs 3% of GDP. If we do climate tax, so CO2 tax, we can reduce this by 0.4%. Innovation can do a lot more. We should also focus on adaptation, R&D for geoengineering, and prosperity. And with that, I'll shut up and get over to the questions. So thank you very much for bearing with me, and I'll look forward to hear your questions. I'll stop my screen sharing.
Well, I'm back. Thank you so much, Bjorn. Really enjoyed your presentation. We did get a number of questions from people who have been watching. Before we get to the substantive questions, though, as you know, I shared with you a Duke Chronicle, the Duke student newspaper article that was protesting your talk here and recommending that we not permit you to talk. And I shared that with you, and I just wanted to give you the opportunity, if you wanted to respond to some of those criticisms, given that some of the people in this audience will have seen the article and so.
Yeah, thanks for sharing it with me. And just very briefly, look, first of all, I think people who've actually participated can see that this is it seems to me at least like a pretty ridiculous argument that you don't want to hear this sort of argument, because you do want to know, if we're going to be spending many percent of GDP, how we best spend that money. They did make three specific claims that are just simply false. They said that I've been funded by fossil fuels. I urge you to follow their links. They're just simply silly claims. We have not taken money from fossil fuels. I have not taken money from fossil fuels. And the claims that we're funded by Coke or by Exxon are simply false. And they also say that I've been convicted of scientific dishonesty. Actually, that was a claim made in Denmark. It was later overturned. The original verdict was actually invalidated because they gave no explanation. They actually made no indication of where it had been wrong or where it had been dishonest. They simply said, which a lot of people seem to like, said, oh, we don't want to hear this guy. So they're referring to a judgment that's invalidated and was no longer correct because it was not documented. And honestly, I think it was also phenomenally wrong. So I just think it's slightly discouraging that we don't have an honest and open conversation, but instead have people say, we don't want to hear you because, and then false claims.
Okay, so let's, thank you for that. Let's turn to some of the questions. One of the questions has to do with the Paris Agreement, since this is the one that most people are familiar with, and it was shocking for this person to hear that you don't think it's very effective. So what are the assumptions that underlie your judgments in that case? What are the Paris Accord commitments that you find to be so irresponsible or expensive? Just share a little bit more about your view on the Paris Accords.
Sure. So the point that I make is the Paris Accord has made promises out to 2030. And what I show is what will happen if you just make those promises. That's the one that the UN Climate Organization, the UNFCCC, estimates to be worth 63 gigatons, 63.5 gigatons. Remember, over the 21st century, we'll probably emit about 6,400 gigatons. And if we want to get to, we'll emit about 7,500, but we need to cut about 6,400 gigatons over the rest of the century if we want to get to 1.5 degrees, which is what the most optimistic assessments say. So basically, the Paris Agreement promised 1% of what you need to do. Now, a lot of people will then say, but we're going to promise more in the future. Possibly. We're certainly going to promise a lot more in the future, but actually delivering it is obviously also going to be a lot more costly. So my point is simply to say, you can't say, here's a treaty that we've agreed on. This is what we're going to do. This is the cost that we're going to look at, the 1 to 2 trillion a year. But we're going to promise a lot more, and we're going to compare it to that. That simply seems to me to be unreasonable. It's also not how you've done the analysis in the past. And if you're going to look at a much greater promise, so basically these promises that we'll get to much, much higher levels of decarbonization, that promises much higher declines in CO2 much, much sooner, you also have to include that cost. That's not the Paris Agreement. That's much more than the Paris Agreement. So I've done a period paper on this, showing what is the impact of the Paris Agreement if we just do it this once. What's the impact of the Paris Agreement if we keep that promise for the rest of the century, so that we'll be about 6 to 7 gigatons below the baseline for the rest of the century. Those are the outcomes that I described to you as 0.029 degrees centigrade and 0.17 degrees centigrade reductions. These are run on the standard UN climate model. If you promise a lot more, and if you actually deliver, of course, you're actually going to see a much lower, much higher reductions in temperature, but the cost will also be much, much higher. And that was what I showed you with the Nordhaus model. So I think it's very clear the current Paris model has not delivered, or is not promising very much, and will not deliver very much at fairly high cost. We can obviously promise much more, and that's going to be even more costly. And again, the costs and the benefits just don't jive up.
I'm going to try to combine some of the questions because we did have a lot of them, and most of them had to do with certain assumptions that people felt you made that they'd like you to articulate or speak a little bit more about. One is, what sort of discount rate were you using in calculating future GDP growths, et cetera? A second was you expressed great confidence in innovation. What is that based on? If innovation is something that we can't foresee how well it's going to do. And finally, the third one, it seemed that you supposed that governments could get together and actually work together to accomplish some of these goals, say building dikes. What gives you that confidence, given the political economy of the world, and the fact that in some of the countries that most need it, they are the poorest countries. So possibly you're not going to have access to those sorts of government funds.
Yep. Three great questions. So the discount rate I use is the empirically estimated one by Nordhaus, which starts out at about 4% and ends up at about 3%. A lot of people would argue, especially in the climate area, that we should have much, much lower discount rates. What that basically means for people who don't know is that we value the future compared to the present much, much higher. But if you actually assume that, you're implicitly assuming that everybody today are saving way too little for the future and is actually willing to, and I'm paraphrasing a little bit, are essentially willing to just eat porridge for their whole lives and leave everything to the future. We don't actually do that. So empirically, it's false. But I would also argue that when you work with most governments, we work with a lot of developing country governments, that's just simply an incredibly privileged first world focus. So in the first world, we can have a discussion about whether we are 3 or 5% or maybe even 2.5% discount rate. But for most developing countries where we've been working, so in Bangladesh and India, in Haiti, we've just worked in Ghana, now we're working with Malawi, all of these countries have discount rates that are 10% or higher, simply because they care about their right now. And that shows us that the investment, the innovation, I wanted to get, so let me just answer your third question. How are governments going to get together and do dikes? Well, the beautiful thing about most adaptation is you don't need to get a lot of governments together. This is something mostly an individual government can do for adaptation. So very clearly, you can even have sub-national levels in Holland and many other places that get together and safeguard a significant area. So that can very clearly happen. You don't need these big multilateral agreements to achieve that. If you think about the Bangladesh point, and maybe I just rushed too quickly ahead from that, but the real issue is to recognize that even in the fairly skeptical outcome, the UN estimate that the Bangladesh will be about as rich as Holland is today in 2100. Of course, they can afford this sort of protection. And again, the question then becomes, do you want to help future people in Bangladesh incredibly ineffectively through climate policy? Basically saying, yeah, sure, you're still going to get flooded, but slightly later, so 1 or 2 years later out in 2100 through climate policy. Or do you want us to make sure that we actually focus on policies that will make you and your descendants much richer, hence much more resilient, much more able to do things like, for instance, Holland does? Those are the real trade-offs, and I think we need to be honest about those. Again, those are real trade-offs, and I'm not saying I have the full answer, but I'm simply saying we should look at that. The innovation bit that you asked, your second question, is no, I don't have certainty that we're going to innovate the solutions. We don't know, nobody does. But I think we can say with certainty, or with a fairly high degree of certainty, that the current approach to solutions haven't worked for the last 30 years and have very little chance of succeeding into the future. So I often find it very, very surprising when very, very honest and clearly very concerned policymakers are saying, I'm so concerned about global warming that I want to do more of the same policy that haven't worked for the last 30 years. So, and allow me to just make a very hand-waving argument, because you can't really do this better. We did the analysis, but I can't guarantee you. It seems reasonable to me that when we look at humanity's history, we've been very, very good at coming up with innovations. So over a 40-year period, say, there's a very good chance that we're going to come up with technologies that are going to be very close to or even cheaper than fossil fuels. And if they're very close, we'll also have a much better chance of actually fixing climate change, because we only have to convince the world's nations to pay a little more rather than a lot more. That seems very likely, let's say 95%. It seems very unlikely that we're going to succeed with the current raft of proposals. We're going to get a little bit of the way, and then we're going to have most people actually defect. Let's say it has 5% chance. I would much rather go with a cheaper policy that has a 95% chance of success than a policy that is much more expensive and only 5% chance. That's roughly the argument that I'm making, but obviously you'd need more time, and we'd need to have a greater conversation on this to explicitize this.
Okay, I think we have time for a couple of more questions. The first one is about geoengineering. This is certainly something that a lot of people haven't heard about. Some of the people wanted to know a bit more about it. And if it's so cheap and so effective, what are the potential bad consequences that would keep us from not undertaking this? And then I'll also, since we're having to go back and forth, I'll give you the final question. What do you think explains the current situation? Why are people so, in your view, misunderstanding the nature of the problems of climate change?
Yep, those are great questions, both of them. So on geoengineering, fundamentally, we know, for instance, a volcano in the Philippines called Mount Pinatubo erupted in 1991. It spewed up lots and lots of sulfur dioxide into the stratosphere, essentially creating a slight haze around the world. It's 1 to 2%. But given that global warming is actually a fairly small imbalance in our in the radiation that comes into Earth and goes out from Earth, it's enough. And it actually measurably cooled the Earth about about a degree Fahrenheit for 18 to 24 months. So we know this happens in nature. And what they're basically proposing is similar things to mimicking how nature works, but in a way that would create a sun shield, if you will, or a heat shield for the world. It's not very much, but it's something that you could potentially and reasonably do that would turn down the temperature enough to counteract most of the negative effects of climate change. Not all of them, nothing does that, but much of the impacts of, for instance, wouldn't handle acidification of the ocean. So this is basically a way of saying we could tackle much of this problem. Now, the idea here is to say, because we've been so focused on putting up solar panels and wind turbines, because that's the only politically correct way to tackle global warming. I'm paraphrasing a little bit here, indulge me. We have paid very little attention to other ways, like, for instance, geoengineering. So fundamentally, we've had almost no research in it, and there's been almost a ban on people looking into this. Most people go, crazy if you talk too much about geoengineering. It's become a little more okay to look at now. That's why we don't know whether this has some really bad consequences lurking in the shadows. It may be that our initial calculations show that this will work beautifully, but we've actually not done any of these large-scale experiments that would allow us, and certainly large-scale climate modeling that would allow us to know, does this have any bad consequences? It's very unlikely that we have something that'll have no negative effects. So we need to know what those are, and we need to investigate them. That's why I'm saying we should not start it now. And I think that's pretty much the consensus view across everyone. Don't start it now, but we should start looking at it so we have that information. Remember, if there's something really bad lurking out there, like the Western Arctic ice sheet slipping off, which would be really bad for the world, then no climate policy, standard climate policy, put up more solar panels, that kind of stuff, could have any impact on that. But a geoengineering proposal could potentially reduce global temperatures in a matter of years or even months or possibly even days. And so that has a real opportunity, and I would argue it's the only real opportunity we have to tackle the really bad outcomes from climate. So that's a sort of insurance policy, if you will. It's not quite, but it's sort of like that. And it's also potentially a very cheap way of achieving some of the mitigation. So again, we should look into it, but we shouldn't be starting now, and we certainly shouldn't be assuming that this is just going to this is our get out of jail free card. The last question is a very good one, and it's essentially a very, very different one. It's, why is it that the notion that I've just presented you is global warming is real? It is a problem. It's 2, 3, 4% of GDP by the end of the century. It is a real problem, but it's not by any means the end of the world. And I've shown you empirical data for that. I've shown you what the economists tell us, and this is pretty much what all economists show us. And I've also showed you, when you do the cost-benefit analysis, you should do some, but not all of it. All of this is fairly uncontroversial. Why is it we have a totally different understanding of the world? I would argue that that's because we are a species that love bad news. And if you look back in time, we've done this many, many times before. 50 years ago, we worried about running out of pretty much everything. Limits to growth, if you've ever heard of it, or look it up. If you think back on acid rain in the 1980s, all of these had kernels of truth and lots of exaggeration. So for instance, acid rain was biggest in Germany, but it was also very big, and it was a very big controversy with Reagan when he was president in the US. If you look at Germany, where they worried the most about it, a majority of the German population literally believed that acid rain was so bad it would eradicate all forest in Germany by the year 2000. Of course, that was not at all what happened. They actually have more forest now than they had back in the 1980s because they're rich and can afford to reforest Germany, as most rich countries do. But the real issue is it's very easy to get caught in this loop of hearing ever more bad news. Remember, bad news sells really, really well, which is why most news outlets that depend on either your eyeballs or your clicks or your subscription will sell you a lot of bad news. Most people don't hear the good news. Almost everyone hears the worst case scenarios of the bad news. And there is bad news from climate change. So you could certainly say this is a problem. Again, as I pointed out, sea levels will rise. That will be a problem. It'll cost us, some around 0.004% of GDP. That's of course not a good story. So instead you go with saying 187 million people are going to get flooded and possibly drown. That's a much better story, much more fun. At the same time, politicians get a chance to promise to save the world without actually having to pay anything, because they get to promise we're going to go carbon neutral in 2050. And of course, somebody else will actually have to pay most of that. So for politicians, this is one of the best outcomes, because you get to say, you are doomed unless you vote for me. And that's what politicians are doing across the world. It's very, very effective. It also gets you lots of opportunity to play the savior, but not actually having to pay, or not having to pay all that much. It's unsustainable in the long run, but it's a great short-term policy for almost any politician. So it's also great for most international organizations and so on. So you have a lot of pressure on telling the worst story. There is a sense in which this is politically the most important issue. Remember, many people in the world actually believe this is the most important issue in the world. Whereas if you ask most real people in the world, of course, they tell you, because most people are poor, they tell you they want their kids to have a good education, they want to have good health care, they want to have their kids not starving, they also want jobs and no corruption. Those are the top 5 outcomes of the global survey of what people actually care about. That's not what you hear, because that's not what sell papers, that's not what get presidents elected. And that, I think, is why we're at this point. I'm not arguing that I can change that with this sort of talk, but hopefully I can get us to a slightly more rational point of view, where we can see, oh yeah, there are lots of problems, but there are also some costs to what we're trying to do. We need to balance the two. And if you leave with nothing else than that from this talk, I'm happy that we at least have had that conversation that is a rational or more rational way of thinking about how we deal with climate. Thank you.
Bjorn, thank you so much for a very provocative and interesting talk, and for spending a little extra time with us in order to answer our questions. So with that, I'll bring this episode to a close. Hope to see you again in real time, real space. But I've enjoyed this very much. Thanks again.
Thank you. And thanks to all of you.